Hey everyone, welcome back to Code with Me. In this chapter, we'll be diving into one of the most powerful and advanced topics in C programming, pointers. If you master pointers, you'll have a deeper understanding of how memory works and how to write more efficient programs. Let's get started. First, what is a pointer? A pointer is simply a variable that stores the memory address of another variable. Instead of storing a direct value, a pointer holds the location where the value is stored in memory. Think of it like this. If a variable is a house, then a pointer is the address of that house. Instead of giving directions based on landmarks, you give the exact address where the house is located. Declaring and using pointers. A pointer is declared using an asterisk. Here, int ptr means ptr is a pointer to an integer. And num gives the address of num. PTR is called dereferencing, which gives the value stored at the address. Pointer arithmetic. Pointers can be incremented or decremented, meaning they can move through memory locations. C includes stdio.h, int main. Int r equals 10, 20, 30. Int ptr equals r. Points to the first element of the array, print f, first element, cent dn, ptr plus. Move to the next element, printf second element, tent r, ptr plus plus. Print third element, tar, return 0. Since an int typically takes 4 bytes, incrementing a pointer moves it by 4 bytes in memory. Pointers and arrays. Pointers work closely with arrays because the name of an array is itself a pointer to its first element. C includes stdio.h, int main, int 1, 2, 3, 4, 5, int ha ptr equals r. Pointer to array for int I equals 0, I plus 5, I plus plus. Printf, element cent d, I ptr plus I. Accessing array elements using pointer. Here, ptr plus I accesses the elements of the array using pointer arithmetic. Pointers to functions. A function's address can also be stored in a pointer. This is useful when passing functions as arguments. C hack include io.h, void greet, print hello from function pointer n. Int main, void functr equals greet. Declaring a function pointer, funcptr, calling the function using pointer return 0. Pointers to structures. Pointers are also used with structures to manage complex data more efficiently. C include stdio.h, struct person, char name 20, int age. Int main, struct person p1 equals alice 25. Struct person ptr equal in p1, print name, nade and name. Printf age cent dage, return 0. Here, we use ptr name instead of ptr.name to access structure members using a pointer. Memory allocation and deallocation. In C, we can dynamically allocate memory using malloc and free it using free. Allocating memory for an array. C includes stdio.h, include slib.h, required for malloc and free int main, int r, int size, printf, enter the number of elements, scanf, cent d, and size. R equals int malloc, size to size of int. Allocate memory for size integers if r equal with null. Printf memory allocation failed n, return 1. For int I equals 0, I size, I plus, ri equals I plus 1. Print cent d, ri. Free r, free allocated memory. Printf memory freed successfully, return 0. Here, malloc size to size of int allocates memory for an array. Free r releases the memory back to the system. Real life example, swapping two numbers using pointers. Normally, swapping two numbers requires a third temporary variable, but with pointers we can swap them directly. Here, we pass addresses of x and y to swap. Inside swap, we use pointers to modify the original variables. Real-life example, dynamic memory allocation. Let's write a program that allocates memory dynamically for an array and then frees it. And that wraps up Chapter 8. If you found this session helpful, like, share, and subscribe to Code with Me. See you in the next chapter.